Okay, well, today we are going to do a walkthrough, a code walkthrough for the second milestone of your big project, which is due on Monday. But before we start, are there any questions on, I think we had a homework assignment due today, but it was just another translation problem. Any questions about that? Okay, so let's go ahead. I was going to take some time this at the beginning of class to do a little demo of the translation problems that we did last time, but I think I'll postpone that because I think we want to go through this in a lot of detail. Now, so let's start with figure 7.37. And here again, this is a translation program that translates from this little toy language, and it shows the principles that you will need to do your translation from PEP9 assembly language. So it's a different language. So you can't just, this code doesn't work for your program, but all the principles that are used here are a guideline for how to do your translation project. So let's just remember what the language is. In this language that this translator translates, it has a set of mnemonics, a group of mnemonics called set and mul and div and stop and end. And then this language has some parentheses with a couple of arguments maybe, or maybe some of them just have one, like the absolute value just has one argument. And some of them have no arguments, so the stop and the end are unary. And then what your project, and then what this translation program does is it does two things. First of all, it parses the program, and if there are no errors, then it outputs the object code, as shown in this output part of the figure on the right. And then after it outputs the object code, it outputs the program listing in a format that is canonical. In other words, standard, in the standard formatted output. Now, what your project is going to do, what your program is supposed to do for Monday, is it will not do the object code. It will just do the program listing. But the program listing, the statements have to be printed out exactly with the exact same spacing as it's printed out with the desktop app. All right? So now what we're going to do is we are going to go do a little code walkthrough to see how this program works. And we'll skip the object code part. All right? So here we go. Okay. Oh, and here in the next part of the figure shows, and I think we went over this before, what the error messages are and how they work for this particular toy language. All right. Now, starting in figure 7.38 now, what we have is a set of enumerated values that correspond to the mnemonics of this language. So, for example, this m_mul mnemonic corresponds to this mul instruction, where you see where it has mul position and excel. So each one of these mnemonics corresponds to, each one of these enumerated mnemonics corresponds to one of the mnemonics in the instruction set of the language. And that in Java, that's going to be in a separate file, right? Now, one more thing I should mention is all of this code is available on the book site, the textbook site. If you go to the resources section, and there's a button that lets you download all of the programs from the text, and this is one of them. So you have access to all of this code from that site. Okay, so now let's take a look at, there's a set of maps, and we've seen how Java maps work, and this program uses 3 maps. There is a map called unary mnemon table, another one called non-unary mnemon table, and another one called mnemon string table. So we've seen before the concept of a map. It's based on a key-value pair. And what kind of a map is it if the key is a string? Remember, if the key is a string, it's a what kind of map? It's a hash map, right. Whereas if the key is a mnemonic, what is it? It's a what? Well, it's an Enum Map, right? So here what happened, the way you set this up is you say public, static, final, and you don't say whether it's a hash map or an Enum map, you just say map. And then you give the types of the key value pairs. So here we're declaring unary mnemon table, non-unary mnemon table, and mnemon string table, right? And then you use this keyword static, and you initialize them with new. So here we have, under static, we have unary mnemon table gets new hash map. So that's, now why is that hash map? Because the mnemon table has what for the key? What type for the key? String, okay? And you see how to populate this table. It's unary mnemon table dot put, and then quote stop, and then the mnemon mstop. Now, so we did this with the planet examples. Does everybody see how to populate these tables? And then similarly, the non-unary mnemon table is for neg, abs, add, sub, mul, div, and set, because those have a parentheses with arguments in them, all right? Whereas the unary ones don't have arguments, so that's just stop and end. Does everybody see? Yeah, question?
What about the one?
Yeah, right. This is just looking up the mnemons.
Okay.
Yeah, and you'll see how we handle that in a minute. The question is, what about the arguments? Yeah.
Can you, arguments?
Yeah. So we're going to look them up separately. So see, what's going to happen is when we go through and parse, when we look up when we get an identifier token, what we will do is we'll extract the string value of that argument, and we will use it to look up. And if that way, we'll look it up in one table. If it's not there, we'll know it's not that kind, and then we can.
Okay.
You see what I'm saying?
Both these are hash. Okay.
Yeah. Yeah. Is everybody good? And then here on the next part of the slide is the Enum Map. So now this is going the other way around. What's the type of the key in mnemon string table? What is the type of the key? It is a what? What is its type? Yes, it's an enum. Right. But then, and so we look up the enum, and what does it give us? The string mnemonic, the way we want it to be capitalized. So how will yours be? What will your tables be for your mnemons, for your assembly language mnemonics?
Caps.
They were all caps. That's our canonical way to display it in the program listing. Is everybody clear on how that's different? And what this does? That's the purpose of this table. Okay. Now, in figure 7.39, we have the UML class diagram for what is called an abstract argument, all right? And this abstract argument is, what does this correspond to? Well, let's go back to our app in figure 7.37. You see, let's take a look in the program listing. You see the command is set, and what are the two arguments? Time, well, yeah, the very first one, time and what? 15. So you see that, and then the next set is, and by the way, what is the type of time? Yeah, it's an identifier, which is a string. But well, on the other hand, the 15 is a what? Is an integer. Are you with me? But on the other hand, the second one doesn't have to be an integer. You could say set t squared comma time, in which case both of them are strings. Are you with me? So here's the thing. Each one of those arguments can be one thing or another thing. So what's the idea behind this, with this design? What's the idea in figure 7.39 with these UML class diagram? Each one of those is an abstract argument. And what is this open arrow? What is this symbol? This is inheritance, which is a. This means that what? An ident_arg is an abstract arg, and int_arg is an abstract arg. So you see this one abstract argument can be either one of these two things in the instruction. Are you with me? So what we do is we set it up to be abstract, And then it could be either an integer or a string or an ident. Is everybody clear on this, on the idea here? Okay, so here we have, so here an ident arg is an arg, and int arg is an arg, is an abstract argument. Right? And what does the ident arg have for its attribute? The ident arg has a what? A string for its attribute. And what is that minus? That private. Okay? But then, and then ident arg is public, but ident arg has the same name as the class ident arg, so it must be a what? A constructor, exactly. So when we set it up, when we do the new one, and we give it a string, and it will set its attribute to that string. And int arg is the same way, only with an integer value. Is everybody clear on this? And that's because we have two different kinds of arguments in the instruction. All right? So here in figure 7.40 is the Java code that corresponds to that UML class diagram. So notice at the top we have, and here again, each class has a different, is in a separate file. Okay, so abstract public class arg, and it specifies one method called generate code that returns what type? What does generate code return? A what? A string. Because the code that gets generated is just a string. All right? For the argument. And now, what is the Java keyword that does this inheritance? What's the keyword that does this inheritance? What is it called? Extends. So public class ident arg extends arg. So our ident arg is a subclass of arg, and it has a private final string ident value, so that is its attribute. And here's the constructor, public ident arg string, and so the attribute gets the value that's passed as the parameter. Are you with me? And now there is, it also has to implement the generate code. So how does it implement the generate code? It just returns what? What does it return? The ident value, which is the string. So that's the code that gets generated. Okay? And why does it? Because look, let's just go back and take a look at the generated code. Do you see the first statement in our program listing in figure 7.37 is set time, comma 15? Well, look at the object code. What is it? It's time, left arrow, 15. So that time is the string that got passed back to the code generator. See, because time appears in the object code, T-I-M-E. Does everybody see? That's why that returns the ident value. And then the arg, the int arg extends arg. It has the same kind of constructor, and its generate code returns what? Now look at what it returns. It returns what? String dot what? Format, and then what? We have the D placeholder and the int value. So it turns it into a string. It turns the integer into a string. Now why is that? Why does it return that string? Let's go back again. Here to our program listing. When it said set time, comma 15, what is the object code? Time, left arrow, what? 15, and that's the string value of the int. Does everybody see it returns a string? Is everybody clear on that's why how that does its it returns that string for the int arg.
And something else is returning the arrow.
Yes, something else is returning. Yeah, in the generate code. Actually, we'll see that. We'll see that. Yeah, we'll return the left arrow. Yeah, because see, this is just the argument. You see, this is just returning the string for the argument part. Yeah, good observation. Okay, and now I think in figure 7.41 we've already looked at this because we did a little bit of a code walkthrough of this when we did when you were working on your tokenizer, right? So this is the way the tokens are set up in this little language. We have an identifier, an integer. In this particular language, we have a comma as a separate token, even though we don't have a comma in our project. And a t-left paren, a t-right paren, a t-empty, and a t-invalid. So we have already looked at this. And also we looked at this class A token. And and how each one of these extends a token. So you've done all this with your lexical analyzer. But are there any questions about this at all? I think this is, maybe one thing that we should look at is that, actually there is one thing that we need to look at here that's going to come into play in a minute. Let's take a look at public class T identifier extends a token. Now check it out. First of all, its attribute is, so we have public final string type capital S string value. So string value is its attribute of that identifier, right? And also the constructor, it just sets the attribute to the what got passed in the parameter list. But now here's a new one that we're going to use in a minute. We're going to see in a minute. Let's take a look at this public string get string value. Now what does get string value do? It returns its what?
String value.
Yes, and the string value is its attribute. So here's what you should do. You should think of these tokens as being wrapped up in a box. You know, so when you get a token from the when the parser gets a token from the tokenizer, it's going to get that token, and from that token, it needs to be able to extract the attribute from it. So if the parser gets an ident, a T identifier. If it gets a T identifier token, it needs to be able to extract the string part of it so that it can build a code object out of it. Do you see what I mean? On the other hand, if it gets here the next one is T integer. If it gets a T, let's take a look at class T integer. It extends a token, a private final int value. So an integer token has an int value that's been parsed and turned into an int value, right? And it has the constructor. But now what does it have? It has a public method called getIntValue. So here, if this one is like suppose the value is like time for its string, and this is an ident value, an ident token, then maybe there will be something like I don't know, 25, and this would be like a T identifier, and this would be something like a T integer. So as the parser gets these, it has to be able to retrieve the attribute part of it. So you see that this getInt value just returns this int value for the parser. So anytime the parser needs the value of the integer, it can extract it from the token that it gets from the tokenizer. Does everybody see how that works? Think of these as like packages that come in the mail, and these methods get string value and getInt value are methods that enable us to get inside the package that comes in the mail and get that attribute out of the package. Are you with me? Yeah, question?
Is there a separate file?
Each class is in its own separate file in Java, yes. In fact, what you can do is I recommend that you download, you go to the resources section of the textbook web page. There's a section called resources, and you can download all the programs from the 5th edition of the text. And if you go into chapter 7, you'll see this entire program. Every one of these, you'll see that you can access the code for every one of these, all of this code that we're looking at here. And you can see that they are in separate files. Each one will be in a separate file. So you can see how that's set up, how that's done. Yeah, question? Yeah, you did. You should build on, yeah.
We're just adding to those.
Yeah. Actually, here's what you'll do. What you will do, here's what, we'll get to this in a few minutes, but what you will do is, the one thing that you're going to have to change is the action performed. Because the action performed will be different this time.
Okay.
But your tokenizer, all the rest of the code in your tokenizer can stay the same.
Instead of
The one thing that'll change will be the action performed. This is what you should build on what you already did before. Yeah. Are you with me? Because the reason we did that finite, the reason I had you debug, the reason we needed to debug our tokenizer is because we're going to use it in this stage. Are we good? Question? Yeah, we're making new files for the parser. Yeah, because you haven't done the parser yet. Yeah. But what I'm saying is you build on what you did before. Yeah. Okay, so are we good? Is everybody, these are all good questions? All right. Okay, so now let's take a look at figure 7.43. Now here again, what we have to do is we have to always go back to the language that we are translating. So here in figure 7.43 is the setup for the code, right? So now here's the idea. The idea is this. Each time, what the translator does is the translator goes through the source code one line at a time. Are you with me? And each time it goes through one line of source code, it gets a stream of tokens from the tokenizer. And as it gets that stream of tokens from the tokenizer, it constructs a code object. It constructs a code object. And there's going to be one code object that gets constructed from each line. Are you with me? Then what it's going to do is it's going to put that in a list. So it's going to put that in a list. It'll put that in the top list. Then it'll go to the next line. It will get a stream of tokens from that line. And as it gets that stream of tokens, it will be constructing a code object. And once it gets to the end of the line, if that's correct, or even if it's an error. If it's an error, it will generate an error code object. But when it gets to the end of the line, it will have a code object, and it will put that in the table. And it'll go all the way through line by line, and when it finally gets to the end of the file, it'll have a table of code objects. Now that is the output of the parser. It's that list of code objects. Do you remember? There are three stages to the translation. Here, let's do this. So let's go back and take a look at figure 7.27. Stages of translation. What is the input to the lexical analyzer? A stream of what? No, the input to the lexical analyzer is a stream of what? Well, very close but no cigar. The input to the lexical analyzer is a stream of what? Terminal characters. Individual terminal characters. The output of the lexical analyzer is a stream of what? Tokens. So we've done that part already. Now the input to the parser is a stream of tokens, and the output of the parser is a what? Is code, is a list of code. And so that, you understand what we're doing now is we're setting up a list of code objects, which is the output to the parser. Once we get that list of code objects, then the input to the code generator will be what? The list of code objects, and the output will be what? The object code, the translated one. Is everybody clear on this? Does everybody see what this overall thing is? Okay, so now let's go back to this. Now let's go back to figure 7.43. This A code, abstract code at the top, that one of these is going to be the output of each line of the parser. Does everybody see what we're saying? And in this particular language, how many different kinds of how many concrete code types are there? Well, let's take a look at the figure. First, there's a what? There's an error code. That's what happens if there's a what? Some kind of error that the user made in the input. Okay, then what's the next one? Empty. That's in case there's an empty line. Okay, is everybody clear? So that's another kind of code. What's the next one? Unary. Now what is the unary in this particular programming language? What are the unary instructions? Do you remember? Stop and end. So that's for stop and end. Is everybody clear? Okay, and what's the third kind? A one argument instruction. Are you with me on that? So that's like neg, like negate. When you negate, that's just only has one argument. Is everybody clear? And what's the next kind? Two argument instruction, which is like set time, comma 15. Yeah. So, okay. But now, is everybody clear on how this relates back to that language that we're translating, how this relates? All right. And now let's take a look. Now let's take a look at the attributes of a one argument instruction. What attributes does a one argument instruction have? It has how many attributes? Two. And what are they? First is mnemonic, which is a what? Mnemon, and that's an enumerated. Are you with me? And the second one is what? An abstract argument. Are you with me? Now, what is this symbol? This symbol is inheritance. What is this symbol? Yes, class composition. And this symbol for inheritance is what kind of a relation? Is a. This one is what kind of relation? Has a. So what has what? Yeah, in this figure, a one argument instruction has a what? Has an abstract, and has an abstract argument, and that's because an abstract argument is one of its attributes. Does everybody see that? Are we good with our UML here? And what about a two argument instruction? What does it have? How many attributes does it have? It has three. What are they? A mnemonic, are you with me? And a first arg, which is a what? Abstract argument. And a second arg, which is a what? An abstract argument. Okay, that's because if you have something that corresponds to something like this, if you say set time, comma 15, then the mnemonic will be the mnemonic for set, and then this would be the first arg, and this would be the second arg. Yeah.
So, like as you wrote it
The parentheses are tokens, but they will go away when we do. They're not relevant to the code.
right, but so
Yeah, the parentheses
those
and.
are just the ones that are being saved as part of the object.
Oh, right. The attribute, oh yeah, that's a good point. So let's think about how you pick the attributes. The attributes of an object or of a class are selected to give you all of the information you need in order to be able to reconstruct either a listing line or generate object code.
Right.
Do you see what I mean? So is all you need to know to generate, suppose you want this to come out in the program listing. All you need to know is that this is set, and this is argument, and this argument, and you can extract the info from this and this, and then you can construct the parens and you can put the parens and the commas back in.
But in order
As you create the listing, yes, that is absolutely correct, and that in fact is what figure 7.46 does.
Yeah.
Figure 7.46 is the finite state machine for the parser. That finite state machine does what you just said.
It doesn't save all.
It doesn't, there's no reason to save the comma, to save the left paren, because, that's a good point. Does everybody see how this is working? This figure 7.46, which is the finite state machine for the parser, takes care of the paren, the comma, blah, blah. But you don't need to save the parens and the commas. All you need in the abstract code is to save what you need to do to reproduce the listing and what you need to produce the object code. By the way, what would the object code for this one be? This one would be set time 15. The object code would be time, left arrow, 15. And all you need to know is this and this. So you emit this, you would emit this, you would emit this, and that would be your object code. And in the listing, it would be set and then time and comma 15. So back to figure 7.43. So then a two argument instruction has a first arg and a second arg, and then and so it has two arguments, right? Now look, you guys, your code, you need to read the problem description in the text about naming these things. One arg instruction and two arg instruction are not appropriate names to use in PEP 9 assembly language. We don't have one argument instructions and two argument instructions. We have unary and non-unary. See, so don't use these names. Don't use. There are some guidelines in the text, in the problem description of the text about naming conventions for these. All right, and then here, so now, on the bottom part of the figure, that's our abstract arg, which is an ident arg and an int arg. Okay, now, are there any questions now about how these classes are organized and constructed, and what are in them? Okay, so now let's see how they work. So here in figure 7.44 is the definition first of the abstract code at the top, so a code. And it has two things, generate code and generate listing, two methods, generate code and generate listing. Now what you will do is, what I recommend you do is you go ahead and put the generate code and generate listing in there, but don't just have nothing for the generate code, just have some dummy value for the generate code. But what you will implement is generate listing for Monday, all right? Your code will do the generate listing. And yeah, the listing is how this comes out. Of course, in PEP 9, it won't come out like set time 15. In PEP 9, it'll come out like this. A typical. Let me see. Now, what were the mnemonics that we had? What were some of the? Yeah. Yours will be dot block like 15, something like that. And then another one could be, what was another one that was not a dot command that you had to do? There was a dot. No, did we have to do dot equate? No. I don't think we had to do dot equate. Yeah, but what was another one? What was another one? Not a dot command. What was like a? Did we have a load and store? Do we have a load word accumulator? So LDWA load word accumulator, and it could be like this. 0x1 0019 comma immediate, right? And so your listing has to come out with exactly the right number of spaces here so that these all line up, all right, in a canonical way, okay? And that's what your generate listing. Each time you do a generate listing, your generate listing has to make stuff come out, make one line come out like this. Now, does everybody see what that is supposed to do? So let's take a look at class error extends a code, and we got private final string error message. Okay, so an error code has a string that is the error message that gets printed out. And then public error, so that is the constructor. So like all constructors, the attribute gets the parameter that was passed. And now look at what its generate listing does. Return what? Return what? Yeah, the error, all caps, concatenated, the plus is concatenated with what? The error message concatenated with what? A new line character. So why is that? You see, that's what's responsible for doing this in figure 7.37. Program listing, error, second argument not an identifier or integer. So you see that second argument not an identifier or integer, that's going to be what? The attribute of an error code. Does everybody see that? So that part will be identical. Set that. Yeah, in the parser. And when you construct, we'll see that in a minute. When you're going through the parser and you get to something, in the parser, it's a finite state machine and it's the direct code implementation. When you get to a point where you say, I'm in this state, and you say, if the token is this, do this. If the token is this, do this. Else, it's not one of those tokens that you expect, then what do? If it's not one of the tokens that you expect, what's the last else? Else, it's an error. So else what you'll do is you'll create an error message, you will create an error code object, and you will put in there, you will know in the code what went wrong. Suppose that that it was supposed to be in addressing mode and it wasn't in addressing mode. Then the error would be error, expected addressing mode, or something like that. And that's that you'll create in the parser. You see, that's how you know. You will know by where you are in the parser. Right? Now here's empty. The empty one, what is it? Here, what's our generate listing? What is our generate listing? Just do what? Return a what? A new line. Okay, that's okay. Now here's unary instruction. Now look, what were the unary instructions? They were what? End and stop. So check this out. So we have a mnemonic, right? We have public unary instructions, so that's the constructor, like the usual constructor. And now what is our generate listing? What is our generate listing? Return what? What is our generate return what? Maps dot what? Mnemonic table dot get what? Mnemonic. And what is the mnemonic? That is the enumerated that's stored in the code record. And so that's a table lookup for what gets printed out for the unary instruction. As we populated the mnemonic string table here's using the mnemonic string table, using the mnemonic to look up what gets printed out. Is everybody clear on that? Okay. And then with the generate code, we'll look at the generate code later. All right. And now here is a one argument instruction. So what does a one argument instruction have? It has a mnemonic, and it has an abstract arg, and then it has a constructor. And what does the constructor do? It sets the what? The attributes to the parameters. Okay, so the mnemonic gets mn, and this dot arg gets arg, because here arg is the name of both the parameter and the attribute. So that's how, if they have the same name, that's how you distinguish between them. Is everybody clear on that? All right. And now what does this generate listing do? So this generate listing, for example, let me see. This is a what? A one arg instruction. So an example of a one arg instruction would be like, in this language, would be like neg position, and with all kinds of spaces. You know, could be in the input there could be all kinds of spaces. But now what gets printed out here? String dot in generate listing. What does generate listing give us? Return what? String dot format. Now what are the placeholders here? %s, parentheses, %s, parentheses, and new line. So the first placeholder gets what? Looks up, it gets this neg from the string table. Are you with me? So maps.mnemonstringtable.get mnemonic, and then what's the second one? Oh, and then what does it? It prints out the paren, this left paren, and then what does it print out? It's the argument dot generate code, and the argument dot generate code returns the what? Position, and then it prints this paren. Are you with me?
Well,
so this is how you're going to print out your addressing modes. This is the same way you'll print out your addressing modes the same way, because your argument, one of those, instead of being an argument, it'll be an addressing mode, and you'll have to insert the comma and then the addressing mode.
which is being printed out from the generate listing part.
Correct. Well, which is being returned from the generate. That's a string that gets returned. It's actually not getting printed yet. It's returning a string. The string will ultimately get printed. We haven't seen that code yet.
Okay, but the string that's being returned.
Yeah, let me. Okay, say you are right. So return string format. So maps.mnemonstringtable.get mnemonic returns the neg, and then it prints out this, and then it calls arg.generate code. Okay, but not one arg instruction generate code.
Great.
That was a little confusing, wasn't it?
Yes. Okay.
So it calls arg. Now, so what does arg generate? Now, didn't we see that before?
It just prints out the.
Let's go back to the arg. Yes. So let's go back to figure 7.40. The arg generate code just returns that.
Great.
Yeah. Oh, good point. That was a source of confusion. Yeah. The argument generate code. Yeah. Yeah. So that generate code is not that. That's an arguments generate code. This is the one arg instruction generate code. So let's not look at the 1arg instruction generate code. That's coming up later. All right, and now the 2arg does the same thing, okay? Only thing is, you see here the generate listing. It prints out, it returns string.format, and then it has, only this time instead of neg position, this would be like set, well here, it would be like this, like set time, comma 15. So here it would be like, so the maps.mnemon.stringtable.get mnemonic prints out the set, and then the left paren in the format string gets printed, and then the first arg.generate code would print out this, and then the comma, and then the second arg.generate code, and then this. Okay? And then we won't look at the generate. This generate code is different from that generate code, and so we won't look at that. And the figure 7.45 is the lexical analyzer, and we've already looked at that. And then in figure 7.46 is the parser. Yeah, question? Now, let me just, okay, it's about time to quit. It's time for us to go. So let me just skip. Unfortunately, this code in figure 7.47 with the parser is the code that implements the finite state machine for the parser. And I think I'm going to let you look at that yourself, and we will go over it on Monday, even though, okay, so looks like we're going to have to postpone the due date. Why don't we give an extra 24 hours, right? And have this due on Tuesday. And so, but I'll let you study this over. But let me just mention one more thing before we break. And that is in figure 7.48, here is what your action performed should look like. You need to rewrite your action performed. All right, so your action performed in figure 7.48 is going to be in buffer gets new in buffer, and then translator.tr gets new translator.in buffer, or sorry, parentheses in buffer, and then we call tr.translate. And then in tr.translate, what we have here is, what you should look at is, in figure 7.47, is public class translator, and it has a constructor called translator, and then it has a method called parseLine, and then the translator gets called, and then this translate in figure 7.47 is what calls the parseLine in a while loop. Anyway, I think, so look this over. We'll continue going through this code walkthrough on Monday. But I think, it was study that, I think we got a good start. Yeah. All right, see you on Monday.